Okay, students, welcome back to the Structure and Bonding Unit 2 series. So this will be the third video for this lesson. So far we have discussed, in the last video we discussed the types of bonds, types of covalent bonds, non-polar, polar, dating bonds, and in this video what are we going to discuss? We are going to discuss now Lewis structures. Lewis structures. So if you cover this part, that means you have covered a lot in unit 2, okay? What I mean from that is, like, if this is the basic, okay? Because from this section only, structured essay A-level question is made. You know that one structured essay out of 4 structured essays, one structured essay is from unit 2. And that question, and this question is mainly based from Lewis structure. So if you pay attention to this video and if you understand, try to grasp what I am trying to explain, that means you have covered, that means you win, like you can answer any questions that will be asked in your question, okay, in your paper. Okay, then let's start this. Now Lamai, there are 3 types of Lewis structures. 3 types of Lewis structures. The first one is Lewis dot dash structures. The second one is Lewis dot cross structures. The third one is Lewis dot structures. So in this video or in this unit, we are mainly focused on this one. Right? In this unit, we mainly focus on Lewis dot dash structures. In A-level, what you should know from this so that you can answer in A-level is how. Now they will give you a molecule PCl5. You must be able to draw the Lewis dot dash structure of that molecule. Okay, you must know how to draw that dot dash structure within few seconds. For now, it will take some time to draw one structure. You might take 5 to 10 minutes, 10 to 20 minutes sometimes. But as you continue to deal with these types of questions, you will easily, like, your time to draw that structure will reduce. So don't worry, we will cover everything in this video. Okay. Okay. Now please pay attention to this one. Okay. Okay, Lewis. Now we are going to discuss Lewis structures. So Lewis structures, Lewis structure is the other name for Lewis dot dash structures. So if I say draw the Lewis structure for this, what you should do is draw the Lewis dot dash structure. That's the standard way. Okay, that's the standard way of representing a structure. The Lewis dot dash structure is a standard way of representing a structure. Therefore, we generally call it Lewis structure. In A-level, they will say draw the Lewis structure for this. And you should draw the Lewis dot dash structure, not the Lewis dot crossover dot structures. Okay, you just forget those things. Those are not easily asked in the Okay. Lewis structures. To draw Lewis structures, there are 2 methods. There are 2 methods to draw Lewis dot dash structures. First method is number 1, inspection method. Now this method is used to draw simple structures. Okay, simple structures. So simple structures, and not for complex structures at this level. When you keep on drawing structures, you will come to a point that you don't need to do anything. You just, when you look at the structure, you can complete the Lewis structure. They will give and explain it later again. There are two methods. Calculate. First one is inspection. Second one is calculation method. Calculation method. Okay. Leave this aside. For a minute. We will learn about it later. In this video, we are going to focus on calculation method. Okay, calculation method. Okay. Okay. First step. Now what are we going to do? We are going to draw Lewis structures. Okay. First method. There are some steps. There are some steps to draw Lewis structures. Now we are going to learn in this video how to draw Lewis structures. Okay, how to draw Lewis structures. Pay attention. There are a few steps. Okay, this is the first step. Now we are using the calculation method. Okay, calculation method. This is the first step. Now my first step is identify the skeleton. Identify the skeleton. What does that mean? Now this is our example. We are going to draw the Lewis structure for N2O molecule. N2O molecule. Okay. Identify the skeleton. So you draw like this: N2O, N, O, N, O, N. These are the skeletons. So out of these two, you should select one. You have to select the most suitable one. Okay, you have to select the most suitable one. So we select the most suitable one by deciding who is the central atom. Okay. The central atom will carry some features. The central atom will carry three features. Three features of the central atom. The first one is, it will be the least electronegative atom. It will be the least electronegative atom. Second one, it will have the highest valence atom. It will have the highest valency. That means it will have the capability, out of all the atoms, it will have the capability to form multiple bonds, to form the highest number of bonds. That is what meant by this statement. Okay. The highest valence atom means that atom is the atom among these atoms that will have the ability to form the highest number of bonds. Third feature is first one, it will have the least electronegative atom. It will be the least electronegative. Then it will have the highest valence atom. Then the third one, it is the least repeated atom. Now let's say a molecule PCl5. This one, who will be the central atom? These three. So among these three features, it can show, carefully listen now, it can show either all three of them, or two of them, or either one of them. If it shows one of these characteristics, 2 or 3, it belongs to the central atom. PCl5, who is the central atom? P, because this is mostly repeated. So if we take what else? COCl2, COCl2, Cl2 is highly repeated. So this will be the terminal atom. This is not the central atom. Cl2 is high repeated. Okay. Then amongst carbon and oxygen, who will have the highest valence? Who will have the least electronegativity? Carbon, oxygen. Carbon. And who is the central atom? Carbon. That's how you pay attention to these three features to determine the central atom. Okay. First step is to identify the skeleton. So among these two, who is the most suitable structure? The middle atom has to be least electronegative. Okay. Among these two atoms, nitrogen and oxygen atoms, who will be the least electronegative? Nitrogen. Because oxygen electronegativity is 3.5, nitrogen 3.0. So nitrogen. So this will be the most suitable structure, most suitable skeleton. Understood the first step? Now let's go to the second step. Okay. In the second step, calculate the total valence electrons. How do we calculate that? Now we know from the first unit, you might know that the valency of nitrogen, valence electrons of nitrogen. Now what is meant by valence electrons? The total number of electrons in the valence shell of the atom. 1:2, 2:2, 2p3. What is meant by the valence shell? The outermost shell. So this is the outermost shell. So number of valence electrons, total of this 2 plus 3 equals to 5. Is the valence electrons of an atom, of an element. What is meant by valency? That you will learn later and explain it later. For now, just remember valence electrons means the number of electrons of the outermost shell of an atom. 2 plus 3, 5. So here now, we should calculate the total valence electrons for this molecule. Nitrogen 5. So 5. We have another nitrogen, then 5, and oxygen 6. The valence electrons of oxygen is 6. You can check and see. Will be equal to how much? 10 plus 6, 16. So this is the total valence electrons. Okay. Then the third step. Let's go to the third step. Now in third step, what happens is we should calculate valence electron pairs. What is meant by valence electron pairs? Now we know the total valence electrons. Then valence electron pairs means total valence electrons divided by 2. So electron pairs means 2. Total valence electrons divided by 2 will give you the number of electron pairs, valence electron pairs. Okay. So for this one, 16 divided by 2 will be 8. Okay. Then the fourth step. In fourth step, what we do is we draw the structure, we draw the proper skeleton. N, O. Okay, N, O. We draw the suitable skeleton, the most suitable skeleton. Then we subtract 8 minus 2 equals to 8 minus 2 equals to, okay. But in this step what we do is we calculate the number of lone pairs. Now what is meant by lone pairs? The valence electron pairs that are not involved in bonding. So identify the difference between lone pairs and bond pairs. This is bond pairs. So lone pairs mean the number of electrons that will be not participating in the bond formation. For example, H2O. So these are bond pairs, these are lone pairs. Understood? These are bond pairs, these are lone pairs. Okay? Okay, now calculate the number of lone pairs. Lone pairs will be equals to how much? We don't need to draw this structure for now. Okay. Calculate the number of lone pairs. Lone pairs will be equals to total electron pairs minus bond pairs. Total electron pairs here it is 8 minus 2 will be equal to 6. So there must be 6 lone pairs. There must be 6 lone pairs of electrons. Okay. 6 lone pairs of electrons. Now, as the fifth step, let's go to the fifth step. In fifth step, what we do is we draw the structure. Okay. We draw the structure, and then we fill the structure with lone pairs. In the fifth step, what do? We draw the most suitable structure, and then we fill the structure with lone pairs. How do we fill it? Now we have 6 lone pairs. There are 3 atoms. So how are we supposed to fill it? Now we start filling the terminal atoms. This is the central atom, this is the terminal atom. We start filling the terminal atoms first. After filling the terminal atoms, if there are remaining lone-electron pairs, we come to the central atom. We fill the terminal atoms first. Now we have 6 lone pairs of electrons. We fill the terminal atoms in a way which will fill their octet. What is the octet? Octet means 8, right? 8. Octet means 8. So I am going to fill the terminal atoms so that there will be 8 electrons in its valence chain. There will be 8 electrons in its valence chain. So I start filling with the terminal atoms. 1, 2, 3, 4, 5, 6, 7, 8. Now this is a bond. There are 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Is the octet complete? Yes. Is there are 8 electrons around the? No, we complete the octet. Okay, octet is complete. Of oxygen. Is there are 8 electrons around oxygen? Yes, complete. Then nitrogen. Again, I have how many lone pairs are remaining? Out of 6, 3 done. I have 3 remaining. Again, 1, 2, 3, 4, 5, 6, 7, 8. 8 complete. Yes. Do I have anything remaining? No. Do I have any lone remaining? No. Okay. This is the 5th step. Now 6th step. As the 6th step do is we calculate the individual atoms. We calculate the formal charges. Now, you know, right, these atoms will have some charges on top of them, right? CO3 2 plus, there will be minus marks on top of oxygen. We have a little bit of like there will be some charges on top of atom. Now we are going to calculate the charges on top of atom. Okay. Formal charge is equal to its valence electrons of the atom. Total valence electrons of the atom minus number of electrons it carries in the structure. Number of electrons it carries in the structure. So this is the equation for calculating the formal charge. So formal charge for, now this is the structure of N O. So now we are going to calculate total valence electrons of oxygen is 6. 6 minus number of electrons it is carrying is 8, right? Yeah. Total valence electrons of oxygen is, no, number of electrons it carries is around 8. 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is equal to minus 1. So there will be minus 1 on oxygen. We usually don't indicate 1, no, we just indicate 1, minus. Then around nitrogen. What's the valence electrons of nitrogen? 5. 5 minus number of electrons it is carried. Number of electrons it carries. Number of electrons around the nitrogen. 1, 2. Now, what I meant by number of electrons it carries is 1, 2, 3, 4, 5, 6, 7. You might think, yeah, 7, 8. No. 1 electron is donated by nitrogen. 1 electron is donated by this nitrogen. Electron is donated by terminal nitrogen. 1 is donated by central nitrogen. So, number of electrons around this nitrogen will be number of electrons around that nitrogen that carries, the number of electrons it carries is 7. 1, 2, 3, 4, 5, 6, 7 at this electron. Okay, 5 minus 7 equals to 2 minus 2. This will be minus 2. Here, for the central nitrogen, 5 minus number of electrons it carries is 1, 2. 5 minus 2 equals to plus 3. It will be plus 3. Understood? It will be plus 3. So for now, take this down, and then let's 7. Pause the video and you can write this one. Okay, let's go to the 7th step. Seventh step, right? Now we know this is the structure. We neutralize the formal charges in the best possible way. So what is the structure that we did before? N minus 6 minus 2 N 3 oxygen minus 1. So we neutralize the charges by transferring electron. You transfer this electron here. So this electron here. So what happens is you transfer electrons by forming a bond, transferring the N 1 2 N N minus. So how many pairs of electrons are remaining? 1 2, because this one transferred here. Now charges. In last video what I told is donating electron. That donor will have a positive charge, will get a positive charge, and the acceptor of electrons will get a negative charge. Acceptor of electron will get a negative charge. So what will happen? Minus 2 plus 1 will be minus 1 minus 1 plus 3 accepting of electron, then plus 3 minus plus 1, so plus 2 plus 2. One now here I make this lone pair of electron or this lone pair of electron here. So we'll check and see what are the structures that is obtained. What are the structures that is obtained in 1 2 3 in oxygen. So donating one pair of electron, then plus 1, so plus minus, so now it's minus here now. If he donates, he will get a plus 1, then plus 1 minus 1 equals to 0. Charge on him is 0. Plus 2, he is accepting a pair of electron, then he will get a negative charge. Plus 2 minus 1 equals to plus 1. Plus 1 minus plus 1. And it also can be like this. Donating this pair of electron to form a bond, then minus 1, donation means he will get a plus charge, then minus 1 plus 1 equals to 0. Here plus 2 is donating, so sorry, he is accepting, nitrogen is accepting, so he will get a negative charge. Plus 2 minus 1 equals to plus 1. Okay. Now out of these two structures, what will we prefer? Now you can't draw any structures in this picture. You have to select the most suitable one. You have to select the most suitable one. In this one, what do we select as the most suitable one? Just think, take a second and think. With your unit 1 knowledge and as what you know, then just take a moment to think. Okay. This is the most suitable structure. This is the most suitable structure. Why? We decide the most suitable structure. I take 2 points to decide the most suitable structure. Okay, 2 points. You have to write these 2 points down. I negative charge to the most electronegative atom and the positive charge to the least electronegative atom. Negative charge to the negative charge I give it to the most electronegative atom, and the positive charge to the least electronegative atom. So these two, nitrogen, oxygen. Who is the most electronegative? Oxygen. So I'm giving the negative charge oxygen. And the second point you have to remember is the molecule will try to keep its charge separation. So these are the 2 points that you should remember to decide who is suitable. Decide who and who wants to start. By these plus and minus. It is separation now, you know. These charges for structure and formal structure. Oxygen minus on the structure is not a, it's not just an answer. So charge separation is charge separation minimum, okay now? And third point, as another point more suitable is the suitable structure. Adjacent atoms doesn't have positive charge. Doesn't have single right three down, right? Right is going down. I will explain later again. Remember this. Now, what I mean by this now. There are two similar charges. What is written is written the structure is stable. So this one stable or this one stable. This is stable because two at the similar. Take this three down. This one and most is as a movable structure. Yeah, this is Lewis structure for N. This is Lewis structure for 2. You can go to video by discussing question. So we will discuss some other fourth video and then let's go to the fifth video. So now go to this video and how to